All right, so 1-4 was graphs of functions using transformations. So these are not an exact location other than the one single point that is your shifted point from 0, 0. The rest of them are approximations of them. If I wanted a more accurate graph, then after I shifted it, I would plug in points like left of right of that center point so that I could figure out exactly what's happening. So number 1 is a parabola. The parent function would be f of x equals x squared. And what's happening to this graph? Shifted up 3. Good, Dina. So I would come over here, shift it up 3 places, and draw my parabola. That's 1. Everybody's good on that one, right? Yeah, okay. 2 is parent function of a square root function, right, which is your little arc. The -1 underneath is causing what? Right 1, and the -4, down 4. Okay, so I'm taking my graph, I'm going to the right 1, I'm going down 4, and I'm plotting my initial point, and then the square root function points up and to the right. Good on that one?
If you did the downward, like you did the other half of the parabola.
So if it was this,
yeah, would that be wrong?
That's if there's a negative in the front of the root. All right, 3 is your absolute value function, which is your v, the parent function. The +2 inside is a shift in which direction? Left 2, the -3, down 3. So left 2, down 3, and then your absolute value should be a v. There should be a difference between your parabola and your v. Make sure that your v has that sharp edge and your parabola has more of a gradual curve. Still with me? Yeah. Okay. 4, back to parabola. Parent function is x squared. What's that 1/2 tell you? It's stretched. Well, it's shrunk if you're using that word. Yep. Or wide. And the -2 is down 2. So I'm moving down 2 places. And I'm making it wider than my normal. Or a vertical shrink, because the ceiling would be caving in on it, pushing out those curves to be wider. Number 5, back to absolute value. So parent function is absolute value, which is a v. And I've got lots of little parts. So the negative on the front of the 5, what's that causing? Say again?
A reflection over the x.
Good, over the x. So it's upside down, over the x, over x, upside down, any of that. The 5 is doing what? It's a stretch or narrow. What's the -1 doing inside? Right 1, and the +2 up 2. So I've got right 1, up 2, facing downward and narrow. Questions on your test you can expect to be more like that. There's going to be multiple shifts, multiple transformations in one graph. You're not going to get one with just like one change. And then 6, square root function is your parent function. The x underneath causes what? Over the y. Or pointing left. And then the +3 is up 3. So for 6, I'm going up 3, plotting a point, and then instead of pointing to the right, I'm pointing it left. Make sure you'd be able to identify domain and range on these. Make sure you'd be able to identify increasing, decreasing behavior on these. Okay? You can get asked all these questions. And just so I'm really clear, when WebAssign does not say graph using a graphing utility, I expect to see you guys graphing these by hand. You need to know how to graph them by hand. So some people are taking pictures of their graphing calculator graphs and submitting it as their homework. I'm not okay with that. You're not going to be able to have a graphing calculator for these questions. So I've been a little lenient up to this point, but it will stop. Unless it says the words on a graphing utility or use a graphing utility to graph this and then answer questions based on it, you should be graphing by hand. You will not have a graphing calculator for most of your tests. You're only going to have it for the one component that we talked about yesterday where you'll have to graph it, and it's not going to be something you can graph by hand. And then you'll have to answer questions based on it, like max min, increasing, decreasing, domain range, all that stuff that we talked about yesterday. The whole rest of your test, you will not have a calculator. So don't get used to graphing using them. Not the piecewise functions, not these functions, okay? You won't have one. Is that clear? I don't want anybody to be surprised that they get handed a graphing question and they don't have a graphing calculator. All right, so this is one of the questions from the homework where they gave you the graph and they want you to figure out what the equation is. We know it's a cubic function, right? So I know it's an x to the third. And I know that typically my x to the third goes up to the right and down to the left, which means this is either a reflection on the front or inside, because with a cube root, either one is the same. I'm in a cubic function, either one's the same. And then what else do you know about the shifts? It goes up, which looks about 2, and it goes left, right? 3, 4. So it looks like my shift left is 4 and up is 2. On a test, you'll have little tick marks, so you'll know exactly what those are, okay? So if it's left, so if I'm using this one, then a left would be x plus 4 cubed and up 2. So I would look to see if that's in the list there, and that's not that one, sorry. That's this one. And then remember that if the negative is on the inside, it changes the shift, right? It puts it over the y-axis. So if I put the negative on the inside with the x, instead of a plus 4, I want it to be a what? A minus 4. And that's where the other one comes into play, which is here, okay? And then this one doesn't work. That's left 4, that's up 2, but that's not upside down. And then this one, left would be right 4, up 2, and flipped upside down, so that one doesn't work. This one would be right 2, up 4. No, yeah, right 2, up 4, and upside down, so that one doesn't work. And this one would be right 4 and up 2. That one doesn't work. So it's just those two in there. Questions? Other questions on homework? Yep.
What is negative x minus 4? Would that be right 4?
Yeah, what did I just say? No, it would be left 4. This one you mean?
Yeah.
So if the negative's on the inside, remember it changes the reflection. So it either flips it over, like if I had just flipped it. There's 2 ways to look at those. One is do it in the direction you normally do. So 1, 2, 3, 4, up 2. Plot your curve. But then the negative on the front of that x flips it over the y, which is why it goes back the other way. That's the one way to look at it. The other way is if there is an x on this term, it actually changes the direction of the horizontal shift. So instead of going to the right 4, it's moving to the left 4.
Okay, and if it's on the outside, that's a flip on the
Upside down, correct. All right, so we're going to talk about 1.5 today, which is combining of functions. You're getting back into like f of g of stuff and g of f of stuff like this. This is standardized test heaven, okay? So these are all the things you can do with functions. You can add 2 functions, you can subtract 2 functions, you can multiply 2 functions, you can divide 2 functions, and then a combined function is taking one function and plugging it into the values of x for the other one. All right, so hopefully most of this is straightforward, with the exception of the notation on the quotient. Like when you see this, right, if the g of x is in the bottom, you still have the same domain restriction you have with every other function. If there's a variable in the bottom, whatever's down there can't equal 0. So if I'm taking g of x and I'm plugging it into the bottom, I have to pay attention to a restriction, which would make whatever's down there not equal to 0, and then figure out your domain from there, okay? These function notations mean exactly the same thing. So that f open dot g means take g of x and plug it into f of x, which would be like this. If it was the other way around, you work right to left or innermost parentheses out. So I would take f of g and f of x and plug it into the g of x. So we'll walk through some examples of that, but the order of those letters is important. Whatever comes second or innermost parentheses is what you're taking and plugging into the other one. All right, so the first thing you're going to see is a graph. It says use the graphs of f and g to graph h, which is the combination of f plus g. So you're adding f of x and g of x. These look a heck of a lot more complicated than they are. All you need to do is go dot by dot and add your two y values. So on this dot and this dot, my g of x is -1, my f of x is 2. If I add those together, I get what? 1. I put a point there. Then I go to the next one, and it's 1, or g of x is at 0, and f of x is at 3. Add those together, and you get 3. And then I go to the next one. 1 plus, it looks like a half, would be 1.5. I plot that point. And then 0 and 2, I add those together, and I get 2. And then I just connect those 2 points. So it went from 1 to 3 to 1.5 to 2. That's it. If it said to subtract the values, I would have done, let's say it said f minus g of x. I would have taken the values of f and subtracted from it g. If it was the other way around, I would have taken g and subtracted it from f, okay? If it's multiplication, you multiply the two together. If it's division, you divide them. But from a graph, all you're simply doing is getting those individual points, the y values that match the x you're given. I added, so this one is a half, and this one is 1.
Okay.
Questions on the graphs? Okay. And then you get the expressions. So this is much more common. It says find A, f plus g, b, f minus g, c, f times g, and d, f over g. And then their domain. So I'm going to start with A, which is f plus g. Whoops. Which means I'm taking 2x plus 1, and I'm adding to it x squared. See if you can simplify, combine like terms. You can't, so I would typically just put this in decreasing degree order. And that is f plus g of x. Then comes f minus g. So I do 2x plus 1 minus x squared. Again, see if you can combine like terms. You can't. So I would do negative x squared plus 2x plus 1. With me so far? Then we get to f times g. So this is not the same as f of g. Those are two different things. Even a solid small dot means multiplication, where an open dot is the combination. So this one, I do f, which is 2x plus 1, times g, which is x squared. Distribute the 2x to both, or distribute the 2x to x squared, and I get 2x to the third. Distribute the 1 to x squared, and I get x squared. And then D is f over g. So I put 2x plus 1 over x squared. And again, see if you can simplify it. Can I cancel something from all three spots? No, so it stays that way. Directions also said find their domains, right? So is there a domain restriction on A? What are we looking for?
All of them.
It's all real numbers, but what are we looking for? When do you know there's a domain restriction?
There's
A square root in the denominator, or a variable in the denominator, right? Yes? We remember this? Yeah? Okay. So this domain would be all real numbers, or negative infinity to positive infinity. How about for B? Is there a restriction? No. So domain, again, negative infinity to positive infinity. How about for C? Same, negative infinity to positive infinity. How about for D? Now there's a restriction, right? I can't have my denominator equal to 0, which means what? X can't be 0. So in words, it's all real numbers except for 0, and in interval notation, it's negative infinity to 0, union 0 to positive infinity. Questions on any of those? All right, and then they just get more complicated. So now I've got square root functions, okay? So I'm going to start the same way. A is f plus g of x. So I take f of x, and I add g of x to it. Can you add square roots? Only if they are the same root. So only if I had like root 2 plus root 2 could I add it, or root 3 plus root 3 could I add it. These are not the same, so they literally stay just like that. There's nothing you could do about it. But while we're here, let's talk domain. So do we have restrictions on your domain? Yeah. What?
Square root.
The square root has to be, whatever's underneath, has to be greater than or equal to 0, right? So I'm going to do the one on the right first because that's easier, right? X has to be greater than or equal to negative 1. But on the left, you have an inequality and a quadratic, okay? This is where you'd have to solve it. So I'd get 4. It has to be greater than or equal to x squared. I would square root both sides. And I get plus and minus 2 because when I do the square root, I get plus and minus 2. But this is where you have to use a number line and test points. So if my zeros are at negative 2 and 2, I have to figure out what ranges of this number line work for this inequality. So I'm going to take and plug in a point that is less than negative 2, in between negative 2 and 2, and then greater than negative 2, and see which of them works. So if I plug them back in to my original up here, I'd get 4 minus a negative 3 squared, which is 4 minus 9, is negative 5 greater than or equal to 0? No, so it is not that range. It's not going to work. So then I plug in a point from the middle. 4 minus 0 squared should be greater than or equal to 0. 4 is greater than or equal to 0. Does that work? Yeah. So this is going to work in here. And then I would plug it in just to be careful, but usually it's every other. 4 minus 3 squared is greater than or equal to 0. 4 minus 9 should be greater than or equal to 0, and negative 5 is not. So now I've ruled out this portion too. So my range from that is that x has to be greater than or equal to negative 2, but less than or equal to 2. So if you have a quadratic, which is what that is, and an inequality, you have to solve the quadratic and test your points and figure out which one's working. But there's still 2 domains here. Remember, we need the most restricted one, right? So if I want to put that on a number line, clean it up. This first one is saying it has to be in between here and here. And the second one is saying it has to be greater than or equal to 1. And it only works where they overlap, right? Which is where? From negative 1 to 2. Those are the most complicated ones. If you have a quadratic and an inequality, which is what's going to happen when you get a square root. So if you have a quadratic under your square root, that's when you've got to test your points. That's the only time you have to worry about it that way. But it is definitely something you need to understand how to do. Matt, did I answer your question or you figure it out? Okay. All right, so now let's do B, which was the adding. I'm sorry, the subtracting, f minus g. So I'd get the square root of 4 minus x squared minus the square root of 1 plus x. And I can't do anything with that either, so that's my answer. And the good news is we already figured out the domain. It's the same from the first one, -1 to 2. And then I would do f times g. So I get the square root of 4 minus x squared times the square root of 1 plus x. Can you multiply square roots? Can I multiply like root 3 times root 4? Yeah, they just have to be both square roots, right? I can't do a cube root and a square root. It has to be the same. So if I multiply these, the square root stays over them, and then I would FOIL out what's underneath. So I have 4 plus 4x minus x squared minus x to the third. And in order, it looks like that. Now my domain, it would be that whole thing has to be greater than or equal to 0. Which goes back to these. Each of these had to be greater than or equal to 0, which means that domain gets carried down. -1 to 2. I could go through the work of factoring that out, and when I factored it out, I end up with the same thing I got from the beginning when I multiplied it out, so you don't have to do the extra work. And then the last one is f over g. So f is square root of 4 minus x squared over the square root of 1 plus x. Now, technically, this is irrational. You have a square root in the denominator. If that was a single number, I'd make you work it out. For right now, I'm not going to make you rationalize it, okay? We'll get to that later. So you can leave it like this. But how does this change my domain? What did we just do by putting the 1 plus x in the bottom? How's it change your restriction if you have a square root in the denominator instead of just in the top? Well, this now has to be greater than 0, which means, if I go back to this work here, it would have to be greater than -1, not equal it, which means I just take this and change that -1 to a parentheses. So all we've done by putting it in the bottom is rule out whatever makes the bottom 0, which makes it a parentheses instead of a bracket. All right, now we get to the composite ones. So you're basically taking one function and plugging it into the other, okay? Whether it's written as f of g of -1 or f open dot g of -1, those mean the same things, okay? This does not mean multiply f times g and plug in -1. Can't do it that way. You have to take right to left. So I'm going to take -1, I'm going to plug it into my g of x, which is here. So g of -1 is 4 minus -1, God bless you, squared. And I get 4 minus 1, which is 3. So that is now taking the place of this, which means my second step is to find f of 3. So taking what you got from the one on the right and plugging it into the one on the left. Plug it in here, and I get 2 times 3 minus 3, or 6 minus 3, which is 3. And it's a total coincidence that those are the same things. And your end answer is your overall answer. So it's not a two-part answer. You're not giving me what you got for f of -1 and then what you got for f of 3, or sorry, g of -1, and then f of 3. You're going straight to the end. Okay, so if I'm working from right to left, then I'm doing g of f of 2. I'm first going to take 2 and plug it into the f. So f of 2 would be 2 times 2 plus minus 3, which is 4 minus 3, which is 1. And then I'm going to take that 1 and I'm plugging it in place of here, so I'm finding the g of 1. So 4 minus 1 squared, 4 minus 1, which is 3. So g of f of 2 is also 3. Questions? So these are not hard. Don't make them hard by not knowing what to do. Just work right to left, Okay, take one number, plug it in, you get a number, take that, plug it into the end. Just be really careful, because this should be an easy question, but if you don't practice it and you forget what to do and you get to the test and you multiply those out, then it's wrong. All right, find A, f of g, and B, g of f. Then find the domain of each function and of each composite. So I'm going to first do f of g. Now notice this time there's no number. So f of g of x means I'm taking g of x, plugging it into the x that is in my f of x, which means this would be 1 over x plus 3. You with me so far? Now it wants you to find the domain of the function and of each composite. So actually, let me find the other composite first. G of f of x means I'm taking f of x and plugging it into the x of g. So this would be 1 over x plus 3. Now we have to find 4 domains. We have to find the domain of f of x. So if f of x is 1 over x, what's my domain restriction? X is in the denominator. So x itself can't equal 0, right? So the domain, so x cannot equal 0. Domain would be negative infinity to 0, union 0 to positive infinity. That would be just for f. How about for g of x, which is x plus 3? Is there a domain restriction? No, right? It's all real numbers. Or negative infinity to positive infinity. Then go back up and find the domain of the composite function. So from 1 over x plus 3, is there a restriction? This can't equal 0, right? So I would say that x cannot equal negative 3, negative infinity to negative 3, union negative 3 to positive infinity. Will always be what? If there's only one number that you're saying it can't equal. Yep. And then for g of f, is there a domain restriction on this one?
Yes.
What is it?
X cannot equal 0.
Good. Now here's the hard part. If there is a domain restriction for your initial function, it has to carry down into a composite. So if I used f of x in either of my other composite functions, then whatever value I had as a restriction for f of x also applies. So in f of x, we said x can't be 0, which means in addition to it being negative 3, it also can't be 0 for that one. And then the second one already has that it can't be 0. So if I write it this way, then it's negative infinity to negative 3, union negative 3 to 0, union 0 to positive infinity. So again, if there is a domain restriction on my initial function, that restriction has to carry down. So you might get a new restriction like we did when we do a composite function, but I also have to account for the very first one. For g of x, there was no restriction, so I don't have to worry about carrying it down. Does that make sense? The reason, and I'll tell you the reason, is because I can take this and I can plug that in 2 ways. One is I can actually find out what f of g is without plugging in for the variable, which is this 1 over x plus 3. And then I can plug in the 0. And that one's fine. But the other way to do it is to take the 0, plug it into the g. Oh, sorry, it's the other way around. If it was f. I can't plug it into f. The problem is f, not g. Okay, so if I take this, again, one way to do it is take the 0, plug it into the f, and if I do that, I get undefined from the beginning. The other way to do it is to find out what g of f is, which is what we did here. And then plug the 0 in, and either way you get undefined. So it has to carry down. If you have a domain restriction for one, it has to carry down into the other one. Does that make sense? Yeah, okay. All right, then we get back to the graphs. So in these exercises, use the graph of f and g to evaluate the functions. So it's grainy, but if you look at A, it says f plus g of 3. So without the graphs, how would you tell me to do f plus g of 3? Like if I gave you two equations, what would you do? You can add the two equations together and then plug 3 in, right? Or I can find what f of 3 is and add it to what g of 3 is. So if that's the case, I use my graphs here. F is on the left, G is on the right. So f of 3, if my x is 3, then my y is 2. And g of 3, if the x is 3, then the y is 1. And then I just add them together. For B, I would do f of 2 over g of 2. So you're dividing. So I go to my left graph where f is 2, or sorry, where x is 2, y is 0, and where g is 2, y is 2. What's 0 divided by 2? 0. So it said it's f plus g of 3. This means find f of 3 and add to it g of 3. If I had equations, I could add the equations first and then plug the 3 in, but if you don't have equations, you've got to separate them out. So then I went to my graph for the f, was the one on the left, where x is 3, y was 2, right? And then I went to the one on the right, that's your g, where x is 3 on that one, the y was 1, and then just add them together. Okay, so then 2a says f plus g of 2. So I'm doing f of 2 plus g of 2. What's f of 2? 0. What's g of 2? 2. Add them together, you get 2. And then B is your open dot. So this is g of f of 2, which means find out what f of 2 is, take that number, and find it of the g. So what did we say f of 2 was? We just found it. F of 2 is 0. So then g of 0 is 4. Okay. Find two functions f and g such that f of g of x equals h of x. And it says there are many answers. So this is a little like the end of yesterday. We have to find a composite function so that f of g of x is going to equal 2x plus 1 squared. In my opinion, the easiest way to do it is make one thing what's inside the parentheses and then make the other thing what you are doing to that parentheses. So if I were to say that this whole thing, I have to go right to left. So what am I plugging into the other one? What letter gets plugged in? If it's f of g of x. What gets plugged into what? If it is this, what gets plugged into what? G gets plugged into the F. Does everybody agree on that? Yes? I know you're half asleep, but I'm not going to reteach this. So does G get plugged into F? Yes. So then this is what you're plugging in. I can make G of X 2x plus 1. And then what do I want to do to 2x plus 1? I want to multiply by 2x plus 1, or what is it called when you multiply something by itself? I want to square it. So I could do f of x is x squared. So does that result in this if I take this and I plug it in here? Yeah. Do you see that? Easiest way to do it is take what's being grouped together, make that what you are plugging into the secondary one, and then whatever you're doing to the secondary one is what you would make the first one. So if that had said f of g of x equals absolute value of 2x plus 1, how would that change what I just did?
Switch to x squared.
Good. So g of x doesn't change. I would still make g of x 2x plus 1, but then I would make my f of x the absolute value of x. Does that make sense? Yeah, if I wanted to cube it, it'd be cubed. If I wanted to square root it, it'd be square rooted. If I just wanted to take 2x and add 1 to it, then I could do something like 2 times f of x plus 1, something like that, okay? But you want to keep the things that are grouped together, and then remember you're plugging it in right to left. Questions on anything we talked about today? So composite functions is 1-5. We have one more section to go before your test. Notice I didn't use a calculator at all today, okay? Or yesterday. On those 2 sections, you shouldn't use it.